Hey y'all. Today we are going to work with powers of monomials. So we're going to use we'll learn a little bit in a new rule, but we will also incorporate a little bit of what we've been learning last week. So remember, this is your first time at home kind of doing your stuff on your own if you haven't had me. So follow along. I believe this is page 4 of your notes packet. So follow along as I do the notes, and then at the very end I'll tell you what problems you'll practice on your own, and then you will upload pictures of your work to turn in. Okay, so powers of monomials is what we're going to work on today, and we're going to learn that rule. I'm going to see if we can figure out that rule before I tell you what the actual rule is. So to raise a monomial to a power, we're going to use the power rule. So I have this monomial right here. There's an exponent, and I'm raising it to another power. I'm raising it to another exponent. What do you think I'm going to do? Well, let's talk about really quick, because I think you guys can figure it out. Let's talk about this. When I do 3 squared, I'm raising, this is a monomial, a number is a monomial, I'm raising it to a power. Don't tell me what the answer is, tell me what that means. So if you think about 3 squared, what does that mean? That means this monomial times itself. And then that would just give you 9. Remember, that monomial times itself, well, there's ones and ones here. You keep the base, you add the exponents, and then you can get your answer. So let's try to incorporate that into this before I tell you what the rule is. Okay, because it's a little easier to see when I do it with a variable. So x squared raised to the 5th power. Whenever you raise something to a power, just like we did here, it meant that thing multiplied by itself however many times. So this means this monomial, x squared, multiplied by itself 5 times. So 1, 2, 3, 4, 5. Oops. That was the 5th time, but the exponent is supposed to be 2 there. So I multiplied x squared by itself 5 times. Now remember, just like we did last week, you keep the base. All the bases are the same here. I keep the base. There's no coefficient other than 1 in front of them. So technically, you would really just have a 1 there. It doesn't matter. And think about what you do with those exponents. You add them. So 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So x to the 10th is your answer. So I kind of went the old route and decided to show what it actually meant. And then I know this rule when I'm multiplying like basis, I add the exponents. I know that rule from last week. But what's another way you think that I could get this answer of x to the 10th? Any thoughts there? Instead of literally writing it out the whole time? I'm sure some of you are thinking of it. If you just multiply 2 times 5, that's going to give you 10. So really, this is just x to the 2 times 5, which equals x to the 10th. So if you'd like to write it out like this so you know exactly what that means, you can. Or you can remember the rule is I just multiply the exponents. It gets a little bit harder when you have more than one variable and coefficients in front of your variable. So we do need to be a little bit cautious there when we get to those harder ones. Okay. All right, let's look at this next monomial, m7n4, and I'm raising the whole thing to the 4th power. So remember, that literally means this multiplied by itself 4 times. So I could either write it out like this. If I did it like that, then I would need two m's. It's all multiplication, right? So m's go with m's, n's go with n's. So I have 1, 2, 3, 4. Which if I add all that up, that gives me 28. And then I have 1, 2, 3, 4 n's. Which if I add all that up, it gives me 16. I prefer to do it a little bit different. So that's kind of exactly what it means. But if you remember the rule, you can kind of save yourself a little work. So m7 raised to the fourth power. So this is being raised to the fourth power, and this is being raised to the fourth power. And when you're raising something from one power to another, you multiply. 7 times 4 is where I got 28. When I'm raising this from one power to the next, you multiply. 4 times 4 is where I got 16. So whether you want to write it out the long way and see exactly what it means, or whether you remember that rule, either is acceptable. Now, one little thing I want to do on this next one is that C needs an exponent. Okay, so they're raising everything inside of parentheses to the third power. So C to the first gets raised to the third power, and D squared gets raised, to the third power. When I'm raising it from a power to a power, I multiply. So 1 times 3 is C to the third, and 2 times 3 is D to the sixth. So my answer is C to the third, D to the sixth. All right, let's go a little bit harder with some coefficients. So when I add coefficients in here, you're going to want to make sure you raise the coefficient to that given power as well. And then we can simplify the variables with our power rule also. So just like we did before, every single thing inside parentheses gets raised to that power. So 5 gets raised to the power of 2, and x to the 7th gets raised to the power of 2. 5 to the power of 2, that just means 5 times 5, which is 25. X to the 7th raised to the power of 2. Remember the rule, when you raise it from one power to the next, multiply. So 7 times 2 would be 14. So 25x to the 14th power. All right, now they're throwing a coefficient and two variables at us. This variable y needs an exponent. Remember, every single thing inside of parentheses gets raised to the fifth power. So 2 gets raised to the fifth power, x squared gets raised to the fifth power, and y to the first gets raised to the fifth power. 2 to the fifth power. That does not mean 2 times 5. No, 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 no. It means 2 multiplied by itself 5 times. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. You can always check yourself on your calculator also, so be smart about that. X squared raised to the fifth power. When you raise a power to a power, you multiply. So 2 times 5 is 10. Y to the first raised to the fifth power. Multiply those exponents. So 1 times 5 would be 5. So my answer is 32 x to the 10th, y to the 5th. All right, let's be a little cautious on this next one, and I'll show you why. So every single thing inside of parentheses is being raised to the second power. Everything. Okay, so -2 gets raised to the second power. P to the 4th gets raised to the 2nd power, and Q to the 6th gets raised to the 2nd power. Just be cautious on this right here. -2 squared. That means -2 times -2, which would be +4, so be cautious there. P to the 4th raised to the 2nd power. You keep the base and you multiply those exponents or those powers. Oops, I think that's a 2. Whoops, where did I get a 6? So 4 times 2 would be P to the 8th. Q to the 6th raised to the 2nd power. You multiply those powers, multiply those exponents together, and that gives me, Q to the 12th. So my answer is, my simplified answer is 4P to the 8th, Q to the 12th. Show your work, guys. I'm doing this for a reason, okay? I was generous the first week, and I may not have taken off if you didn't show your work, but I am not going to be as generous this week, so make sure. And again, I don't do it to be mean. I do it because it's going to help you in the long run, okay? I want you to see your process of what happens, and it doesn't take you a long time to show your work. All right, let's see what we got to do next. Whoops, whoa, what did I do there? So, get rid of that page. All right, we're going to kind of skip around here. I am going to go to number 9. All right, now this one has a coefficient of 1/2, and then it has 3 variables, and they're all being raised to the 3rd power. Show what that means. That means every single thing inside of parentheses is being raised to the 3rd power. So 1/2 raised to the 3rd power. A to the 3rd raised to the 3rd power. B to the 4th raised to the 3rd power. C to the 5th raised to the 3rd power. 1/2 to the 3rd power. Remember, when I raise a number or to a power, it means that thing times itself 3 times. When you're multiplying fractions, multiply your numerators, so that gives me 1. Then multiply your denominators, and that gives me 8. So 1/8. A to the 3rd raised to the 3rd power. Multiply those powers, multiply those exponents to give me A to the 9th. Same here. B to the 4th raised to the 3rd power. Multiply those exponents. So B to the 12th. C to the 5th raised to the 3rd power. Multiply those exponents. So C to the 15th. So my simplified answer is 1/8, A to the 9th, B to the 12th, C to the 15th. All right, we're going to jump to number 11. All right, now be careful here because it's saying 1A to the 3rd times -1, don't forget to put that 1 there, -1A squared B to the 1st, all raised to the 4th power. So the only thing that's getting raised to a power here is whatever's in parentheses. So I'm going to leave that 1A to the 3rd out front, and I'm going to take care of parentheses first. So everything inside of these parentheses is getting raised to the 4th power. So I had to add that -1 as a coefficient. So -1 gets raised to the 4th power. A squared gets raised to the 4th power. B to the 1st gets raised to the 4th power. -1 to the 4th, what does that mean? -1 times -1 times -1 times -1. Negative times negative is positive. Negative times negative is positive. 1 times 1 is 1. A squared raised to the 4th power. If I multiply there, 2 times 4 gives me 8. And B to the 1st raised to the 4th power, if I multiply, 1 times 4 gives me 4. Now keep in mind here, I still have some more like terms because I had this A up front here. So these A's can go together. When you're multiplying like bases, 1 times 1 is 1, keep the base. What do I do with these exponents? If I have 3 A's and then I have 8 A's, this is where I add them. I'm using that rule from last week. I have a total of 11. This B has nothing to go with it, so leave it on the end. Remember, you don't have to have the 1 in front of it. If you put it, you're not wrong. If you don't put it, you're not wrong. So my answer is A to the 11th, B to the 4th. So take that step by step, follow your order of operations. Remember, parentheses, you get rid of parentheses first, and then you get rid of exponents. All right, let's jump to number 12. Then we're going to try some geometric ones. All right, so let's look at number 12. This one's a little bit more complicated. It's kind of like everything here is being raised to the second power, and everything here is being also raised to the second power. So I'm going to show, this is where showing your work is so important. All right, so everything inside of this parentheses, I got to add a 1 on that A, right? And a 1 on this B. So everything inside of this first parentheses is being raised to the second power. So negative 2 to the second power, A to the first to the second power, oops, B squared to the second power. And then everything here is being raised to the second power also. So 3 squared, A squared raised to the second power, B to the first raised to the second power. So really, this is just one big multiplication problem. I got rid of those parentheses. Now I'm going to finish getting rid of parentheses by doing these exponents. So negative 2 squared means negative 2 times negative 2, which is positive 4. A to the first raised to the second power. A power raised to a power, I multiply. So 1 times 2 gives me 2. B to the second raised to the second power. Multiply those exponents. So that's what? B to the 4th. 3 squared means 3 times 3, which is 9. A squared raised to the second power. Power to a power, I multiply. 2 times 2 is A to the 4th. B to the first raised to the second power. Multiply. B1 times 2 would be B2. Now, can I leave it like this? Again, it's still one big multiplication problem, but it looks like I got stuff that I need to put together. I need to reorganize. Coefficients go with coefficients, A's with A's, B's with B's. So my coefficients first, 4 times 9, I'm going to reorganize it, and then I'll finish my answer. A squared times A to the 4th. Now B's, B to the 4th times B squared. I started showing y'all how I cross it off just so I can see like what I have left. You don't have to do that, but if it helps you, I think that's helping some people. All right, now remember, coefficients get multiplied. So 4 times 9 is 36. A squared times A to the 4th. Remember, when you're multiplying like bases, you keep that base of A. This means I have 2 A's and 4 A's. How many total? If I add them, I have 6. Same thing here, B to the 4th times B squared. I keep the base of B. I have 4 B's and 2 B's, so I have 6 B's. So 36, A to the 6th, B to the 6th. Show your work, so important. Because then if you accidentally get something wrong, you can go back and see in your work. And usually within your work, you can figure out where you made your mistake, and then it helps you make sure you don't make that same mistake again. All right, we're going to try some geometric application problems on the back. So let's go to, or on the next page. Oops, why do I keep doing that? All right, so let's go to number 16. So number 16 says, find the perimeter and the area of each figure. All right, now think about this. Perimeter means, well, what kind of figure do I have here? This side is 5x squared, this side is 12x. If the sides are different, then it means I have a rectangle. Perimeter means you add up all the sides. I don't know what this side is or what this side is. Remember, if this side is 5x squared, this side is 5x squared. If this side is 12x, this side is 12x. So in order to find the perimeter, I can literally add up every side. So I have a 12x and a 12x. I have two 12x's and two 5x squareds. Remember, this is incorporating some memory from last week. Remember, in order to add or subtract like terms, they have to be the same. So this is an x to the first, this is an x to first. They go together. Keep that like term. 12 plus 12 would be 24x to the first. This is an x squared, this is an x squared. Keep the like term. 5 plus 5 is positive 10x squared. Now, can I add these? I cannot because they're not like terms, so this is my perimeter. Now remember with your area on a rectangle is length times width. So if I go ahead and take this times this, I got 12x times 5x squared. Put a 1 here. Remember, coefficients with coefficients, x's with x's. So I got a 12 and a 5. X to the first times x squared. And then I can finish it out. What's 12 times 5? What does that give me? 60? X1 times x2. Remember, if you're multiplying like bases, you keep that base. This means I have 1x and then I have 2x's. So how many total x's? I add them, and 1 plus 2 gives me 3. Now just be cautious here. Sometimes it'll tell me that this is measured in feet or inches or centimeters. If it doesn't tell you, then it's just units. And I forgot to say that when we did perimeter, but the perimeter would you would just say your units. If it was feet, I would just say this, feet. So since it doesn't specify, I'm just going to say units. When you do your area, it is units squared. So perimeter is just the unit. Area is the units squared. So that should be part of your answer. All right, let's try 17. And I believe, yeah, this falls under the same directions. Find the perimeter and find the area. So remember, this is a right triangle. I can tell that because this 90-degree angle right here. So we want to find the perimeter first. Perimeter means I add all the sides. I'm going to add ones here, right, just to help me. All right, so I'm adding every side for the perimeter. 4a squared b to the first plus 10a squared b to the first plus 3a to the first b to the first. Remember, in order to add or subtract, they have to be identical. This is an a squared b to the first. Do you see another a squared b to the first? I do, it's right here. So keep that like term, keep the a squared b to the first. 4 plus 10 is 14. Now this is an a1, b1. It doesn't look like it has anything else to go with it, so I'm going to leave it. I can't add these because this is an a squared b1, this is an a1 b1. They're not the same. Stop, that's it, you're done. All right, area. Area. Does anyone know the area formula for a right triangle? The area of any triangle is 1/2 base times the height. All right, so let's see. We got 1/2. This is your base. And here's your height. This is one big multiplication problem. Just like we've been doing, coefficients with coefficients. So I got 1, 2, 3 coefficients. I took care of those. A's with A's. And B's with B's. Organization, important. So put your formula, substitute for your formula, organize, then give me an answer. 1/2 times 3 times 4. Well, in my head, I would think I can take half of 4 easily. Half of 4 is 2, and then 3 times 2 is 6. You can put that in your calculator and check yourself. A to the first times a squared. Remember, multiplying like bases, keep the base. Add those exponents. I got 1a and 2a, so I have 3 total. b1 times b1, I keep the base, add the exponents, 1b and 1b gives me 2b's. So 6a to the third b squared, and that is units squared when you're talking about area. All right, let's do 2 more like this. And then I'm going to have a couple for y'all to try on your own. We're not going to do number 18, but I do just want to talk about it really quick. It says, assume the triangle is equilateral. What does an equilateral triangle mean? Equilateral triangle means equi. All sides are equal. So if this side is 20 m to the third n to the fifth, this side is 20 m to the third n to the fifth. And this side here is 20 m to the third n to the fifth. They gave you the height here because you'll need that if you were doing the area. Okay, but an equilateral is all sides are equal. But we're not going to complete this one. I want to get to another one. All right, so number 19. Does anybody know what type of figure this is? It wants me to find the area of this figure. Anybody know? This figure is a trapezoid. Hopefully you got that right. Now, the more important question is, does anyone know the area formula for a trapezoid? This one just wants me to find the area. So the area formula for a trapezoid is 1/2 times the height times base 1 plus base 2, because it has 2 bases on a trapezoid. It has a top base and a bottom base. So you add those bases and multiply it by 1/2 times the height. So I wrote my formula down. Next, I substitute for my formula. Oh, I'm going to add 1, so that's probably smart, right? All right, so my height is 2x1, y1. And then add my bases together. I have 4x squared y1 plus 7x squared y1. All right, order of operations tells me I've got to do what's in parentheses first. Now, the only way I can add those is if they are like terms. Are they like terms? This is an x squared y. Is this an x squared y? It is. So keep that like term. 4 plus 7 is 11. And I'm just going to bring down the 1/2 and bring down the height because I didn't need to do anything with that yet. So now really, this whole thing is just a multiplication problem. I'm going to put together what belongs together. Okay, so my coefficients, 1/2 times 2 times 11. Cross them off. Some of you like that. It helps you organize. X's with X's. X1 times X2. And Y1 times Y1. Don't skip these steps of your work. Important. All right. 1/2 times 2 times 11. Well, half of 2 is 1. 1 times 11 is 11. x1 times x2. I'm multiplying like bases. Keep the base and add those exponents. If I have 1x and 2 x's, I have 3 total. y1, y1, keep the base, add the exponents. 1y and 1y gives me 2y's. So 11x to the third y squared units squared. Better see all that work. It seems like it's a lot, but it's not. And I promise you it helps you. It's really important, okay? All right, last but not least, and then you will try some problems on your own and upload all the pictures of everything I did with you and then what you're doing on your own so I can check it. So I believe this falls under, yeah, the directions are the same. It says find the area of this figure. So this is a circle. What's the area formula for a circle? Hopefully you know that it's pi times the radius squared. Remember, this is your radius. Half of a circle is a radius. The full circle would be a diameter. All right, so pi times, I want to square this radius. So I'm squaring this whole thing. All right, remember, you've got to get rid of parentheses first. So it is asking me to square every single thing inside of parentheses. So 3 gets squared, x to the first gets squared, y to the third gets squared. All I'm doing is showing my work. I wrote my formula. I substituted for my formula. Now I'm showing what I need to do. Now let's see if I can finish here. 3 squared is 9. X to the first raised to the second power. Remember, when you raise it from one power to the next, you multiply. So 1 times 2 would be 2. Y to the third raised to the second power. Multiply. So 3 times 2 is 6. Now here, all you need to do, you don't need to change pi to 3.14. You just need to reorganize it. The most important thing is the coefficient comes first. So it's pretty much 9 pi x squared, y to the 6th, units squared. All right, y'all. So that's all the ones that I'm going to do with you. So let's go ahead and see which ones. We're going to circle the ones that I want you to do on your own. So on the very next page, you should see homework number 2. And let's go ahead and circle the ones I want you to do on your own, and then you can go back and do it and show your work, and then you can take your pictures and everything. So number 2, 5, 8, 11, 14, and let's try some of the geometric application ones. Oops. Let's do 22. Now remember, it asks you for perimeter and area. 23 also asks you for perimeter and area. And then, skip 24. We'll do 25, which just asks you for the area. And 26, which also just asks you for the area. So if I count correctly, that is 9 problems that you are going to do on your own. It is also written on your Google slide in case you forget or if I went too fast by accident. And then please keep in mind, you will go ahead and you will take pictures of everything to upload to the assignment on Google Classroom under the classwork tab. Y'all did great the first week. You did awesome on Friday. Please make sure you stick with it, okay? If you have any questions, you can send me a remind message or an email, and I will help you in any way that I can. All right, keep working hard and finish those problems and then upload it and turn it in. You're good for the day. Have a great day.